In this third video for vectors, we're going to be focusing on dot product and its applications. There is such thing as a cross product as well, but we will not be doing that. You may have done that in physics. So the dot product, U dot V, is U1 times V1 plus U2 times V2. So it's the sum of the products of the first components and the second components. So let's try finding the dot product of U and V given here in this example. So the dot product is, and notice my answer is just a number. It's not a new vector, okay? So we have to multiply the first components, and we have to multiply the second components, and then we add our answer together. So the dot product of U and V comes out to negative 40 plus 26, which is negative 14. So the dot product of U and V is negative 14. Our result is not a vector, it is just the number negative 14. There are different properties of dot product. I have them listed here. We're not going to focus on these. I just included this just in case you were interested, or if you see it somewhere else. We're just going to do a couple of applications for it. All right, one application of the dot product is that we are able to use it to find the angle between vectors. Okay, so to find the angle theta that is between vectors U and V, we use this formula. Cosine of theta equals the dot product of U and V over, and then at the bottom, notice those are the magnitudes of U and V multiplied together. All right, so let's try one. We're going to find the angle between vectors U and V, and they're listed. So we're going to do the cosine of theta equals, and on the top is the dot product, so we multiply the first components, we multiply the second components, and we add them together, over, now we need to find the magnitude of each vector, and those go on the bottom. So the magnitude of the first vector, so that is 2 squared plus 3 squared, and the magnitude of vector V is negative 2 squared plus 5 squared. All right, so let's see. We come up with the cosine of theta equals, if we do the top, we come out with 11 over the square root of 13 times the square root of 29. And now we need to find theta, so we are going to do inverse cosine of both sides. At the bottom, you could use parentheses around the whole thing, or you can rewrite it as the square root of 13 times 29 like that, so you don't have to use parentheses. That's up to you. Don't forget to make sure your calculator is in degree mode. So when you did that on your calculator, you found that theta was 55.49 degrees. And you could draw out vector U or sketch it 2, 3. So there is vector U, and then negative 2, 5. And that angle between would be 55.49 degrees. Not a very good picture, sorry about that. Another application of dot product is proving that two vectors are what are called orthogonal. And basically what orthogonal just means is perpendicular. So if we notice the dot product is 0, then we automatically know that they are orthogonal perpendicular. So let's prove that U and V given here are orthogonal. So to prove it, we just have to show that their dot product gives us 0. So multiply the first components, multiply the second components, and we do get 0. Okay, so we were proving it, right there's my work. Therefore, U and V are orthogonal. Now you may be asking, well, why is that true? if we look back at the angle between vectors formula, if my dot product was 0, that would make the top part 0, which means we don't even care about the bottom. And if you think about it, if we're finding an angle that's cosine is 0, then that comes out to our angle being 90 degrees, right? The cosine, the x coordinate is 0. So that is why the dot product has to be 0 for them to be orthogonal. And sometimes they may not focus on orthogonal or perpendicular. They may ask you if two vectors are parallel. Well, parallel means they go in the same direction. So that means we would use the slope formula. We just have to be careful, though, if we have the point 2, 3, and we think, how can I use the slope formula, which has me subtract 2 y's and 2 x's. Well, remember that this vector is 0, 0, and 2, 3 as the two endpoints, initial point and terminal point.